As Bob mentioned, I'm John Simmons, and I work for the Electric Power Research Institute. We are a nonprofit 501c3 for the public good research corporation. So all the research that we do has to benefit the public, and we work in the sphere of energy, electrical energy, and we work a lot with utilities who are always looking for ways to bring electricity to their customers cheaper, safer, more reliable, and more sustainable. The key aspects are we're independent. Because of our funding mechanism, which is membership-based, we can do research, and our results are completely independent. Sometimes people like our results, sometimes they don't. Nonprofit means we're here for the benefit of you. And collaborative, this is kind of key to this whole talk. Collaborative means we bring together different entities to work together on problems. So we'll be talking about collaborative research here today, research involving more than one utility, more than one vendor, more than one university, more than one national lab. So it's a big collaborative effort. We provide really three things: thought leadership, industry experience, and our collaborative models. Most of the people that work at EPRI, we have about 800 scientists and engineers working at EPRI, and most of us have had industry experience either at a utility or somewhere at a vendor or some other entity that is relevant. We have 4 sectors. We call them sectors. Normal companies would call them business units, but there's environmental, nuclear generation, power delivery, and utilization. I work in power delivery and utilization. So if you hear me refer to it as PDU at some point, that's what I'm talking about. But we research absolutely everything having to do with electricity. So if you come and ask me, hey, do you guys research? The answer is yes. All right, I usually show this slide when I'm talking to neophytes to augmented reality. Actually, on the plane flight out, it was delayed, let's say. Multiple tens of hours delayed. So I had a chance to talk to a lot of people, and absolutely nobody I talked to knew what augmented reality was. So it's really important to kind of set the context and let people know this has been around for a long time. It's been in football and baseball since 1998. And most people who have rented a car have had this experience with the backup camera and an augmented reality projection of your course as you pull out of your parking spot. So I usually throw this in there to kind of get people familiar with it, because there's a lot of, when you Google it, there's a lot of kind of impractical, at least currently impractical use cases out there. And I'm trying to show to people that it is here and it is now. All right, some examples. Currently, this is about the only study out there that's been published in the scientific literature anyway, about the return on investment for augmented reality. And it's by Boeing, and it's done by Paul Davies, who's here, maybe not here in the room, but here in the building somewhere. And he's done quite a bit of work in this area, and he's probably one of the experts in this field. But this study is where they took a complex assembly task, and they broke down 3 control groups. They had different ways of getting instructions on the complex assembly. And they did just 2 assemblies. And I want to point out that these were all neophytes to this assembly process. There was nobody that was, an old hand at this. And it showed this dramatic improvement in first-time quality. There's other metrics in the paper on efficiency and whatnot. But if you were here for the last session, people were talking about this double-digit improvement in efficiencies. And this is one example of this. I know Engrain is out there in the vendor area, has got some privately published information based on the Canadian Air Force studies. And there's a couple out there now that are starting to come out. But this is probably the oldest and best known and most dramatic example. So again, if you're wandering around the exhibition hall or you're sitting through a lot of these meetings, you'll find examples, AR examples in all these different use cases. And I put this slide up there to show that maybe with the exception of surgery, all of these exist in the electric utility industry. You can think of the electric utility as being a process industry, a construction company, and a huge PR effort too. The electric grid is the largest, most complex machine ever made by man. And what's really unique about the electric utility industry is that its product is consumed simultaneous with its production. So it's not like, you know, frozen peas or automobiles. There's no inventory involved. It's produced and it's consumed. Actually, it's consumed and then it's produced, because what they track is the consumption. And that brings about certain unique aspects to the business. All right, I wanted to throw up the area slide here. EPRI is a founding member of the area. And so these are some of the folks that we deal with, and in a lot of ways they are pretty much considered to be the leaders in the augmented reality sphere. So if your company isn't a member of area, I would recommend that you go take a serious look at it. There's a lot of benefits, and you'll see a lot of information in this presentation from the area. EPRI uses them as kind of a consolidator of information and research that we can then go in and tap, and access to a lot of expertise. So it's been very, very beneficial for us. All right, so what are the research questions for augmented reality? Well, first there's the economics issue. It was mentioned in the last session in here. People all want to know, what's the return on investment? What's the increase in efficiency? What's the drop in error rates? All of these different issues. There's the ergonomics. What is the impact on the eyes? What is the impacts on the muscle systems, the skeletal systems? Does it make people dizzy? Are there any issues with the weight that you have to carry, either on your face or your head, or in any kind of batteries? And then there's the safety issue. When does this technology become distracting rather than helpful? You know, back in that football example, that's a really great example of augmented reality because it adds to the game without blocking anything. If you remember, well, they still do this, but they put up little frames that say what down it is and how far to go and all this kind of stuff, and it covers up part of the screen. And so you're actually taking away from the game experience to provide information, whereas the augmented reality projects it on there, takes nothing away, it only adds. But there is a point where you start bombarding people with information, and they do things like walk into empty elevator shafts, or they touch the wrong wire and get electrocuted. So safety is very, very important. And finally, data quality. Data quality is paramount. There's no point in projecting bad data. There's no point in giving people bad data or relying on bad data. In the electric utility industry, one of the primary sources of data is something called the geospatial information system, which carries basic asset information, geolocation information, and also the network model for the distribution system. And historically, these data sets have been flawed. Okay, the enablers that have come about as of late to improve things is the infrastructure, the standards, and the technology. Towards the end of the last session in here, people mentioned standards. There are standards for augmented reality. Again, the area is very involved in the standards, and that has a lot to do with Christine Perret, who was the first executive director of the area. And if you need to know anything about standards, go ask her, because she's been doing them for a decade or more. So the utility industry is taking all of these different areas, and we have a semantic standard that you'll see figures prominently in the work that we're doing. But we pull from all of these platform enablers to provide information to the utility worker of the future. We've been doing augmented reality projects since 2000. I think we first introduced it in 2011. Our first project was a proof of concept. It was called Field Force Data Visualization. And it was primarily for workers that go outside into the field. We had 4 members. Remember I said we have a collaborative model. We have 4 collaborators in this. Entergy, who's the energy provider in New Orleans. Gas Natural Fenosa, who has a big chunk of Spain. Consolidated Edison, who of course is in New York. And Long Island Power Authority, who of course is Long Island. And we did a project, it was about 2.5 years long. So the good that came out of this is that we showed that work could be abstracted so that you can use the same user interface for any kind of work. We showed that, in fact, it could be used outside and that there may be value there. And the last bullet there, if you notice, 2 of the utilities were from the kind of the Hurricane Sandy area. And they were very, very interested in storm damage assessment because that's the rate limiting step oftentimes in restoration efforts. So the opportunities, which we always say opportunities when we mean problems, is that the GPS location needs to be enhanced. The GPS location that's typical in an iPad or an iPhone or an Android device is really not good enough. We had challenges with large data sets. We were using an SDK that if you projected too many pieces of data on the augmented reality view, it would simply quit and bounce you back to the screen. Inaccurate GIS data, and you'll see an example of that. Then the SIM standard, this is kind of a utility jargon, but SIM stands for Common Information Model. It stands for 3 IEC standards, 61970, 61968, and 62325, which are standards, are semantic standards having to do with words and their meanings. But it's a very, very powerful standard for us because one of the manifestations of the standard is standard messaging. And during this project, it occurred to me that one of the advantages of standard XML messaging is that it could be generated anywhere and you don't need to rely on the vendor's mobile seat to interface to the back office. So part of this project was that the augmented reality view and the map view provided a lightweight graphical interface to multiple back office systems. So you could talk to the asset management system, the work management system, the outage management system, the GIS, all from the same interface without hopping from application to application. Also had a lot of impacts on the seat licensing. So the economic benefits need to be still assessed. So I wanted to show you some of the data from LIPA because it's pretty cool. This is LIPA data from the parking lot of the Nassau Coliseum where the Islanders play. Any Islanders fans out there? No, well. Anyway, if you were, you'd probably stay at the Long Island Marriott, which is in the lower right-hand corner where that white field is. And this is some of the underground assets. Underground assets in their GIS system are denoted as dash lines. And there's some switch gear in the upper left portion of this. And you know, maps on mobile devices are cool, but that's been around for quite a while. This is the satellite view where you can actually see the Marriott there. And then this, if you were in the concierge floor, drinking a beer like you do, and looking out the window with your iPad, this is the view that you would see in augmented reality, which is a representation of the data that is spatially accurate. So you can literally walk out there, walk across the parking lot, see where the line crosses the parking lot, and just walk by and see it go underneath you. So some of the opportunities here, one of the opportunities I mentioned was storm damage assessment, and I'll talk a little bit about that. But also, like I said, this can be an interface for multiple back office systems. In this case, storm damage assessment, view manuals, redlining, which was mentioned briefly in the last session, but redlining is just marking up drawings. And then getting the asset history. And again, this can all be done using standard messaging. So how storm damage assessment could possibly work is that when there's a large scale outage, like after a hurricane or tornado, you could go out and you could denote whole areas that have been destroyed and get an automatic bill of materials for the folks back in the warehouse to kit up and send out on the truck. And this is a huge time saver. We're talking hours of time that their customers are sitting in the dark because of this. So again, here's some other use cases from the area that are relevant for the utility industry. And go in there, you can see them. Now I'd like to show the video. I think you guys have to start it, but I think you'll recognize the vendor here.
More than ever before, utilities are presented with new technologies with the promise of making work easier. In addition to deciding which tools are useful, organizations have the challenge of incorporating these technologies into their own systems. Getting the most value involves both using these tools and having them be able to send information to each other quickly, as seen in this case. By first combining wearable technology that can identify the equipment, work orders can be entered quickly. Here, the operator uses the as-found checklist for transformers found in EPRI's PM Basis database, quickly sending his observations to the system. Automated analysis tools, like the Diagnostic Advisor in EPRI's fleet-wide prognostics and health management program, can take field observations, compare them against equipment history and operational data, determining the next diagnostic step, open-air acoustic analysis in this case. Without the feedback from the diagnostic system, this would have been split into two tasks taking more time, and without a common information model, these observations would have to be pushed along manually through independent systems, with cumbersome interfaces that slow down the work by having seamless data integration. We can work better together and have our tools and systems work for us for a change. The common information model enables interaction between different systems from varied vendors and flexibility on adding new solutions, keeping utilities free to apply new solutions for a changing environment.
Okay, I probably should have mentioned this beforehand, but that was an example of a transformer inspection. These are the big transformers you find in substations, the really big ones. And this is a typical inspection process that goes on. And the one step that you saw here is they were looking to see if something was overheated, and then they were listening to the fan to see if there was any problems with the fan or the fan motor. So our current project involves bringing together the technology and the utilities, doing collective development of technologies, and where is it? The point I want to mention. Anyway, by the way, that one picture you see is GIS information overlaid on reality, and without getting into a lot of detail, it's all just a little bit off. So that's one thing that has to be worked on. So the current project is called Assessing Augmented Reality. It's there to address a couple of different issues, primarily the economics and the ergonomics. And we're putting together several utilities. I think we're up to 7 now that are participating. and where each utility brings a couple of different use cases, and we inject augmented reality into their workflows, and then we measure things like efficiency gains and error drops and stuff. And then the second half of this is ergonomics. We're looking at the health and safety issues. We're probably going to spend $250,000 to $500,000 in that area, taking a look at the impact. Here's some of the members. Actually, we just picked up another member during the last session, and I got a text from my boss. But Duke Energy, Consolidated Edison, Korea Electric Power, Electricity de France, Amrin's in Illinois and Missouri, and then Enel, which is in Spain and Italy. So here's the process, no big deal. But so the key takeaways from this is that we've got real examples here, we've got real research questions, we've got real opportunities, and we're working on a lot of the issues that were raised in the last talk, the economic issues and the ergonomic issues. So before that thing comes through the wall, I'm going to get off the stage. Thank you very much.